We live in a fast-moving world. All around us, the most extraordinary processes. With access to some of the most fascinating factories, I take you behind the scenes to reveal their production secrets. From craft workshops to international industries. Join me, Francesca Chiorando, as we explore the world's ultimate processes.
In this program, I'm meeting some big machines. This is the world of the modern tractor. Some of the most powerful and sophisticated vehicles being made today. They're packed with the latest technology, computers, touchscreens, GPS, and the engines can turn out up to 315 horsepower. This is the New Holland Tractor Factory in Basildon, not far from London. Today, on Ultimate Processes, we're going to find out exactly how they're made and how they handle.
They begin life on some of the most advanced production lines ever built. Tractors are one of the essential workhorses of the modern world. And to cope with the demands of today's farmers, they just keep getting bigger and bigger. This is agriculture at its most sophisticated. In this program, we will see how these huge machines are built, how they are put to work in the field, and I even get behind the wheel of one myself. Tractors are big business. Over 2 million new machines are sold every year.
And farmers across the globe have to be sure that the tractor they choose is tailored to their exact specifications.
Manufacturers are constantly developing new models, each one more technologically advanced than the last. New Holland has been making agricultural machinery for over a century. They started in 1895. Today, they are one of the largest tractor manufacturers in the world. The biggest tractor plant in the UK and one of the largest in Europe is at Basildon, near London. There are over 1,000 staff and 2 kilometres of assembly line. It's where New Holland produces its huge T7 heavy-duty tractor. A new tractor is finished here every 4.5 minutes, so the production line combines precision engineering with pinpoint timing. Tractor cabs packed with technology, engines painted by robotic arms, giant wheels bolted into place, and a test track primed with planks and potholes. Each tractor is made to order, and everything has to come together exactly on time. And with over 100 years of experience, New Holland runs a tight operation. Tractors have come a long way since they were invented over 175 years ago, and demand has skyrocketed.
Since it opened in the 60s, the factory has churned out over 1.8 million tractors and over 3 million engines. And today, the operation continues to grow.
This plant is the central hub for New Holland's production process. producing 20,000 tractors a year and even more engines. The additional engines are used in other tractors made across Europe.
Basildon Tractor Plant is a final assembly plant. So we receive the major components from our other sister plants within the European region, and that can be the engine, the gearbox, the rear axle and the cab. And then within Basildon, as the hub of the brand, we then put all of those major components together, and then we do the final finished product within the plant and the final testing and everything that goes with it.
The newest tractor New Holland has developed is also one of their largest on offer, the T7 Heavy Duty. Over 3 meters tall, weighing up to 12.5 tons, this giant combines tremendous power with technological ingenuity. A machine at the cutting edge of modern agricultural innovation. Basildon completes the New Holland production process. Smaller parts are shipped in from across Europe and assembled here to create the finished product. The production process is split into 2 parts. The cabs are made in France and transported to Basildon in trucks. Arriving at the factory, they are quality checked. Then, the cabs are loaded onto trolleys, which snake their way towards the plant.
So we're now inside the factory. The cabs have been brought in from the outside, and now the work really begins. Wiring looms are now added to the cab.
The first thing they fit as it comes into the cab line here is the main harness. The main harness is all the looms that we need, which has all the electrical connections that we need to plug all the ancillary parts that we through the cab as it goes through to the line.
The cabs are now ready to be added to the cab line.
The cab line is essentially where a bare shell comes in and it's populated with all the essential parts that go into the cab. The cab is the main hub of the tractor, if you like. It contains all your electronic components, your auto guidance, your remote packs, your steering. So it's basically as the same as a car. It's your main hub of your tractor.
Installing components to the cab takes skilled manpower and pinpoint timing.
There are 39 operators in total on the cab line, and we have 3 group leaders. The tack time for the line at the moment is 5 minutes, so it has 5 minutes in every zone before it moves to the next operation. The main aim of the cab line is to get a quality product off the line every time, first time. It's very similar to a car inside now. We've got a high-spec unit, and we need the farmer to be sitting inside a high-spec cab.
Each cab has to be made to the exact specifications of the customer. With thousands of different variations possible, few cabs are the same. Over on the other side of the factory, the parts that will form the chassis have just arrived. The chassis combines 3 of the tractor's largest components: the driveline, the engine, and the front axle, all of which are made abroad and shipped in. John Williams is in charge of making sure this process runs as smoothly as possible.
We receive our drivelines, our engines and our axles from our sister plant. Our drivelines come from Antwerp or Modena, our engines come from Turin, and our front axles come from Modena.
The parts that need to be added to form the chassis are extremely heavy, so they have found a clever mechanical solution.
Like many modern factories, New Holland ensures it's fast and efficient by using robots. Here, these are called AGVs, Automated Guided Vehicles. Fully automated, they move completed tractor parts quickly around the factory.
It's a bit like watching a ballet. The AGVs form a vast team of robotic helpers, moving parts along the production line. And this mechanical army is kept very busy.
We've produced over 20,000 tractors a year, and of those 20,000, we only produce the same tractor twice. So complexity is my enemy, because we have over 12,000 different variants of each particular tractor based on individual requirements from our customers. So we use some very technical solutions within the plant to avoid the potential human errors with that complexity.
How does the AGV actually work?
The AGV is operated by our computer system. It's a wireless operated system. Sunk into the floor, we have wires which the AGV follows. It's like a giant scale electric. So once the operator pushes the button to send it onto its next cell, the AGV will follow that line in the floor and it will go directly into the cell.
Gliding around the factory, the AGVs perform a crucial role. They move large, heavy components at this early, critical stage of the production line, setting the pace for the tractor build.
We've been using them since the year 2000. That's when they were introduced.
And has it made a big difference?
It's made a big difference to how we've assembled the start of the tractor.
Firstly, the tractor's driveline, the undercarriage that delivers the power to the wheels, is loaded onto the AGV.
From here, the drive lines will go onto the driveline cell, onto a pallet. The AGV will pick that drive line up and take it to the engine cell. The engine cell is then mated to the drive line.
And this 6.7-litre engine packs a punch, pumping out up to 313 horsepower.
Once the engine's been fitted, then the operator pushes a button to send it onto the next cell, which will be the axle cell.
The front axle has reinforced suspension to deal with hazardous terrain and the tractor's hefty weight.
From the axle cell, it can only go to one place, and that's the production line.
The chassis is now ready for the rest of the tractor to be loaded on top. At the New Holland tractor plant, the cabs are now making their way down a production line where thousands of parts are installed. Many of these parts are built in the sub-assembly area nearby.
Everything from the seats to the wing mirrors are put together in this area.
The function of the sub-assembly area is to sub-assemble all of the product and deliver it to the line to be assembled onto the line. From the warehouse, we receive every single part. We put the actual pedals, the boxes, right down to the nuts and bolts and washers and the hardware. In this particular area here, this is the pedal box area where we make the steering columns and the steering wheels.
Pedals are fixed to the bottom of the steering column, and at the top, control stalks are positioned on either side, and the housing is screwed on. Up to 100 new steering columns are completed every day.
And then it's loaded onto the frame there, ready to be delivered to the line. Once this is finished, then the trailer will be taken over onto the line just over there, onto the cab line.
A delay in the sub-assembly area could cause major problems on both production lines, as the cab and the chassis have to be ready at exactly the same time.
Each operation on the line has a time limit of 5 minutes 30 to complete that operation, which means that the pedal box has to get to the line every 5 minutes and 30. If that fails to reach it on time, which means the line has got to stop, then you'll have all the people on the cab line and the main line stopping until that pedal box gets there. So it's critical to make sure that one pedal box gets to the job every 5 minutes and 30 seconds.
If everything in Paul's area runs like clockwork, the whole factory keeps moving. Once the pedal box reaches the cab line, it's matched up with his cab. And the two are joined together. The tractor is coming to life. Next up, the driver's seat is lowered in.
So efficient, it literally just slots in and slides into place perfectly.
And as the cab moves down the line, the roof is winched into position.
The equipment inside is state-of-the-art. A massive wiring harness is packed behind the interior panels. The seat is specially sprung for all those hours spent out in the field, and an armrest joystick gives fingertip control.
The cab obviously has evolved for the needs of the farmer. We work in different climates across the world where air conditioning will come into play. Auto guidance for the cab is something that is Wi-Fi based, you pick up from the internet. It can plot his field, exactly how long his field is. The main effectiveness of auto guidance is when the farmer's seeding his field, we don't have any overlapping on the field when he's doing this process.
The farmer himself can go and put the tractor year on year within 2 centimetres each year on year in the same place within the field. From the tractor owner's perspective, he uses this as a business, so the tractor earns him money. So for every small square inch of the field that he can actually produce product from, then that gives him the advantage. Precision farming gives him more efficiency and then gives him more profits.
The cab is always moving down the line, which means the operators have to work on the go.
They connect their tool trolley to the cab so they can work while moving. Everything is mobile.
This is where they fit the rear fender. They have a specially made seat and tool station so that they can work precisely and efficiently in the small space. I think this is my kind of job.
The tractor starts to take shape as the cab nears the end of the line. The mudguards are slotted into place. Back over on the other side of the factory, the chassis is ready for its makeover.
Obviously, tractors are very practical machines, but we still want them to be a thing of beauty. So a proper paint job is important. New Holland's spraying department uses special robots for speed, but also for safety. But even in an automated process like this, there's still room for a handcrafted finish.
Even stylish supercar brands are big players in the tractor market. They are among the 200+ manufacturers throughout the world.
The paint process in Basildon is a robotic two-coat process. It's a process where we do what we call wet on wet. So we have a primer which is still tacky, is when we apply the top coat.
The chassis is cleaned of any contamination, and then robots take control.
I'm Alan Stone, and my role on the paint floor is looking after the robots, programming the robots and the maintenance of all the handguns.
The chassis is first painted in a grey primer by 2 robotic arms.
The main purpose of paint is basically protection of the tractor, so it has a long life. At the primer stage, it's purely all robots. The robots are programmed by myself by the computer. Robots really are just quicker, more efficient. It's got longer arms than I have, so it does a lot more, really.
Even the temperature is regulated to make sure the paint flows smoothly.
When it goes in the booth, we like to keep it at a temperature of around about roughly 20, 22, because obviously paint flows better in a warm atmosphere and it will stop any condensation. Well, the condensation is going to react with the paint, so then we're going to get an inferior quality paintwork that then affects the customers.
The painting process is also electrostatically charged. The paint is charged positively and the chassis is charged negatively, which means as soon as the paint leaves the gun, it clings straight to the chassis.
So we get more paint coverage, because you can imagine, unlike our cars, the tractors are in conditions which are very aggressive, the environment where they are.
So we're getting more paint on the tractor, but actually using less paint.
Once the primer is on, it's time for the top coat.
Well, the primer is where all your rust protection and protection for all the working parts are. And really, the top coat is more aesthetic and also the UV protection for the primer. It's actually grey, even though it looks black. It is New Holland grey. The top coat is given a first coat by the robots. We get 2 coats in now, and that's just to ensure that we give a full coverage. Obviously, there's a lot of hard work the tractors go through, so we want to ensure the best quality we can give our customer.
It takes 6 litres of paint to cover the chassis. Once the robots have finished spraying, the operators make sure every millimetre is covered.
After we've applied the top coat, it will go then for a break-in period of roughly about 2 hours, about 90 degrees. Then it will go up a stage to about 110 and then back down again. So it's like a 3-stage system, because obviously we don't want to boil the paint.
As soon as the paint is set, the chassis is on its way to meet the cab. Once the paint is dried, another robot takes over, transporting the enormous chassis across the factory. These are called Smart Guided Vehicles, or SGVs.
The SGVs are smart vehicles. They follow location points based on the pillars as you move down the aisleway, so it knows exactly where it needs to go. The SGVs were brought into the plant purely to move the HD from the paint floor onto the new HD line.
Machines like these are vital to ensure consistent quality and efficiency.
The robotic system within Basildon has had a significant improvement on the quality of the finished product because of the repeatability, and it's also had a significant improvement in the efficiency of the plant. We're building over 12,000 different combinations of a tractor. So what we do need to do is employ some of the technology systems, so the automated side of the business, which then gives us that repeatability to take out the variance.
In manufacturing, one of the biggest challenges is making sure every product leaving the factory is of the highest quality. One small slip-up along the production line and thousands of defects could be created. Tractors are everywhere, from the South Pole to the Arctic Circle. And they have to be incredibly durable to deal with the harshest of conditions. Building a robust machine is a top priority. The New Holland plant produces a brand new tractor every 4.5 minutes. To maintain quality across the line, the company is signed up to world-class manufacturing, an endeavour to ensure all aspects of the business are as streamlined as possible.
We introduced in 2008 world-class manufacturing, which is a very scientific manufacturing process, where with that introduction, that gives us the benefits of higher efficiency, better quality, and higher safety for our employees.
World-class manufacturing is very important going forward with the economic way that the tractors are built now. We need to be competitive with the other companies. To produce this, we need to make sure our quality improves, our efficiency improves. We make the tractors first time are built correct and start up first time. This will reduce costs.
During that process, we use a lot of technical solutions, technology. Basically, we use auto-guided vehicles, smart-guided vehicles, we use robotic painting processes, and we also use automated fill processes within the actual tractor build itself.
To minimise the number of defects, New Holland has set up quality gates. This means they can visually check any parts that are susceptible to issues. These quality gates are run by Stephen Whiting and his team.
OK, when we first started recording defects, it was just an inspector on the line, just noting on what I was finding and then recording it on paper, basically. We was getting rumour of a plant in Italy, Pomigliano, Alfa Romeo plant, had set a quality gate system up, and I was invited along to go and have a look and see exactly how they were recording their issues. We came back to England, came back to this plant, and we wanted to improve what they were doing.
Once the cabs reach the end of the line, they're checked at the quality gate. Operators use tablets to check each model individually, taking pictures of any suspected defects.
The tablet is designed to have checks that we've seen repetitive defects. So he'll have a number of checks to go around the tablet. It'll be things like harnesses, harness connections, make sure they're connected and snapped tight. It'll be trim issues, make sure the trim's fitted correctly, make sure bolts are done up, make sure earth leads are connected properly. Various things. Make sure lights are fitted tight and not just left hanging. And there's a number of different things. You could have anything up to about 30 checks per cab. So we prevent a lot of defects going into the garage, which is obviously money and man time used up there. So the company as a whole benefits, and obviously the product and the customer benefits in a big way.
The cab passes the test. Next, a short ride around the corner to await its chassis.
The T7 heavy-duty tractor is one of the largest that New Holland produces. Building this has meant the company has had to make some major changes to the production process.
Tractors traditionally had very basic electronics and were operated with only cables and levers. But a modern tractor has more in common with a jumbo jet than its ancestors. Installing all the parts to the HD tractor requires a whole new way of working at the plant.
The new tractor that we've just released within Basildon, heavy duty, we've actually had to invest in a brand new assembly line because the tractor size and volume outgrew the facility that we had 50 years ago.
The tractor parts are so large they aren't able to fit on New Holland's standard production line. so a new one was built alongside it, allowing New Holland to run both production lines at the same time. The Pedestal line, known at New Holland as the cab drop, is where the two sides of the factory finally meet.
My name is Sam Gibson. I am the team leader of the Pedestal line. I have 43 operatives between 4 different zones. The cab drop is one of the most critical processes where the cab meets the driveline.
But it isn't simply a case of slotting the two together.
The cab drop is where the cab comes over, we lift it up, we prep the pipes, all steering pipes, all brake pipes, then we offer it to the driveline and fix it all up.
A new cab is delivered to Sam's team every 5 minutes. Matching each one to its unique chassis means the system has to be perfect. The cabs hang from the ceiling and synchronize seamlessly with their designated chassis. When both are ready, they're connected together.
On the left-hand side there, he does all the air conditioning systems, plugs that in. At the back on the right-hand side here, he's the man in control with the buttons, which raises and lowers the actual cab itself. And what the guys do on the right-hand side is the electrical connections and all brake connections underneath. With a lot of these new models, there's not a lot of room for error. So everything has to come down in a unique, slow fashion to make sure that, firstly, nothing gets damaged, and two, everything gets connected correctly.
With thousands of specifications available to the farmer, New Holland have to ensure no detail is overlooked.
Within one of my areas, I provide a parts pack, which is like a Haynes manual, which is unique to every tractor. I have just under 600 operator manuals available to me across different languages, different specs, all depending on the options. They say that we don't build the same tractor within a yearly period, so every tractor is quite unique. Everything is slick, everything turns up at the correct time so that we can fit it to the correct tractor.
Everything is linked up, and the cab is dropped into place. Now only one piece of the jigsaw remains, and it's a rather large piece. At the New Holland plant, the T7 heavy-duty tractor is almost complete. There is already fuel in the tank. Waiting at the end of the Pedestal line, the final components.
It's the sheer size of these tractors that make them such awesome machines. Attaching the wheels is one of the final processes, and they really are big.
At over 2 meters across and almost a meter deep, these are no ordinary wheels.
From the wheel area, what we do, there's a company which we use, which delivers our wheels, all different types, all different sizes. They come down onto a trailer. The trailer runs alongside the line, and what we've got is a turntable which comes round and separate left and right-hand side manipulator.
They're so big that on some models, the tractors are first jacked up on a hydraulic ram. This gives extra clearance to then attach the wheels and tyres.
We pick up the rear wheel, offer it up and fit to the tractor, whether it be on the left and the right-hand side. Very safe, very good to watch.
The wheels are positioned under the mudguards and fitted onto the axle. The vehicle now stands at over 3 meters. Because of the incredible weight of the T7 heavy duty, New Holland created their own tyre pressure monitoring system, which is built into each wheel. The driver is able to increase or decrease the pressure from within the cab. The tractor is now complete. In under 2 days, thousands of parts have been assembled to make the T7 heavy duty.
And here is the end of the process, a brand new tractor. But before it can leave the factory, it has to pass rigorous quality control tests. Attention to detail is everything.
First, they are all visually inspected by a team of auditors. From the day's batch of finished tractors, some are taken for more intensive testing. They are now packed with technology, so there are lots of elements to check.
When I first came to the plant in 1988, tractors were very basic machines. There was very limited electronics, and they were very basically operated with cables and levers. Now today, I need a laptop, just the same as we do with our cars, to be able to go and service or do any diagnostics on the tractor. So the technology has far improved since it was 20 years ago.
Everything is ticked off, and once it gets the seal of approval, it's on to the next challenge.
One of the most important tests is what New Holland call the rolling road. It's a clever piece of technology that allows us to simulate different speeds and surfaces. This means we can push this tractor to its very limits, reaching speeds of up to 50 kilometers an hour, all without actually going anywhere. I'm going to join Paul, the test driver, in the cab now.
The tractor drives onto the rolling road area and is lined up on the roller. As every tractor is unique, each one requires its own specific set of tests.
I'll go. Oh, yeah, I'm holding on.
The engines are fired up.
During the rolling road process, the operators are completely instructed dynamically on all of the functions that they need to test on each specific tractor. There's many different variants of tractors, so each of those are loaded into a system so he knows exactly what functions on that specific tractor he needs to test.
The tractor is pushed to its limits. Any slip up here and the whole day's batch may have to be pulled from the production line. If there's one failure, then New Holland has to analyse all of the day's tractors to see if the defect is in each one. The driver floors the throttle and analyses the readings on the computer. The acceleration is checked to see if the engine is reaching its potential. It suddenly gets rather loud. Everything from the anti-lock brakes to the vehicle's tracking are examined. There are up to 110 tests the tractor must undertake on the rolling road. And this one passes all of them. But there is still one last challenge remaining. They line up at the factory exit. Time to go outside for the final test. The machines have been thoroughly vetted inside the factory. Out in the open air, there's a whole different set of challenges. New Holland has built its own test track, full of obstacles and uneven surfaces.
The tractor itself has to be a very robust product because of the environment that we put them in. We have a big investment into the durability of each particular tractor.
They have to withstand arduous conditions and brutal climates.
So we have our own test track within Basildon where we encourage different types of application, and then we can test that to improve the durability of the finished product.
In some cases, gearboxes and engines get more serious tests.
We would receive a tractor from the plant, a sample tractor, and we would run the tractor at maximum speed, making sure all the gears work. We get the tractor hot, and we also put it on a dyno to test the power of the tractor. We'd also run it over the surfaces, the ISO surfaces and the offset bumps.
First up, wooden slats imitate the rough terrain the tractor has to deal with on a farm. Then offset bumps test out the suspension.
Offset bumps are a much more aggressive bump. They don't look particularly aggressive, but if you're going over on a tractor, they are quite severe and would only be done at maybe 1 or 2 kilometres an hour.
A pitted road surface has been designed to make sure the tractor can deal with life down on the farm. The tractor is able to push 50 kilometres an hour. So finally, they put the pedal to the metal and see how it copes at top speed. Finally, the completed tractors are on their way out of the New Holland plant. Thousands of components and hundreds of man-hours have produced this rugged machine. And now it's time to see how well the newest T7 heavy-duty performs in the field. The tractor is finally in its natural habitat. New Holland organises events so farmers can try out their latest machines. Tractors have grown bigger and bigger in recent years, allowing them to cover larger areas in less time. And with so much technology fitted inside this colossus, there is a wealth of useful settings to help the driver.
So I just pull back on my speed slightly, operate the hydraulic raise switch, the implement comes out of the ground, and then I can make my manoeuvre on the headland. Basically what we're doing, we're raising and lowering the implement on this switch here, this paddle switch. I can then engage a set forward speed just by pressing that button there. It takes me up to a set speed where the tractor will drive to this speed. The engine RPM will adjust itself accordingly. So when it hits a tough bit in the field, the engine will increase its speed. When it hits a light bit in the field, the engine will decrease its speed. This is constantly saving the customer money on fuel. He's also getting maximum work rate from his tractor.
This new technology plays an important role in operating the cultivator.
Point the tractor back in the right direction, lower the implement into work, and back up to my maximum forward speed in the field. Effortless.
Everything from how deeply the blades dig into the earth fact, the exact coordinates of the tractor's position in a field are calculated and stored on a USB stick.
Simple as that. The USB stick is now taking on board all the information that the computer system is giving to it.
Then they can be reloaded into the computer when needed. The software can even analyse the data and recommend better ways to enhance production. This ensures the farmer covers every part of the field. And it's not just farmers that need their modern tractors. These vehicles are used for everything, from snow ploughing to building sites. This process is a combination of expert engineering and precise timing.
This is one of the biggest models that New Holland make, and once you're in the cab, you really get a feel for how big and powerful these machines are. It'd be a shame not to give it a go.
In under 2 days, New Holland's team has created a machine capable of dealing with whatever the farmer needs, turning thousands of individual parts into a single bespoke tractor. We've seen the cabs arrive at one end of the factory and engines and axles being delivered to the other. Engines have been connected to drivelines, and robots have given them slick new paint jobs. The tractors are full of the latest technology, from specially sprung seats to intuitive auto guidance technology. The cab and the chassis are married up, and the enormous wheels are fitted into place. We've seen the tractors push to their limits, both inside and outside the factory, until finally getting the seal of approval. Powering production around the world, tractors are no longer lumbering dinosaurs. They are technological marvels. Time for me to hit the open road.